Today we will continue. First, we will recollect what we did so far. So in the first day, we saw what are the database systems. The two main types of database systems, OLTP and OLAP. And our focus is on OLTP. OLTP deals with transactions and OLAP deals with analysis. In any business, there will be day-to-day transactions happening. That data has to be entered into the data store, and that data store is called database. This is OLTP system. And in any business, after having done transaction for some time, you need to analyze the data. That is because you need to report and you need to further take decisions on how the business is going to run based on the data. So in any business, two types of data systems are mandatory, OLTP and OLAP. We are going to see the OLTP system. Data is usually moved from OLTP to OLAP using a tool, ETL tool like SSIS. And if you look at cloud, it is Azure, ADF and ADB. So you have these tools. Now, the next portion we saw was how I convert data which is there in business to the data in my database. So there are a series of steps. The first step is we have to do a high-level design. You have to decide my business is like this. The data is coming in every branch. Let us say, for example, Reliance Fresh. There are multiple branches. The data is coming from every branch. Where do I store the data? Should I store the data in the branch itself, or should I store it in the region like Bangalore, one data center? Or should the data be stored in every store? So these kind of decisions are called high-level design. This is the first process. The second process is converting the data. Business is there, data is present, converting that into logical representation. So logical representation of data is done through entity relationship modeling. So this is modeling. And this is used mainly for OLTP system. We are going to be focusing on OLTP. Then after completing this, we started looking at how we convert what is modeled into tables, because finally we have to use tables only in your databases. So that is called the process of table conversion. Then after you have converted into table, you try to optimize it with two processes called normalization and denormalization. Up to this point, we are just looking at the broad outline, because we are not going to be focusing on modeling in this training, or we are not going to be focusing on design or high-level design in the training. We are focusing here mainly on tables are given to me. How do I implement them in SQL and then take it further? So now tables are ready. Then what is the database engine we are chosen? We have chosen to implement the tables. Tables can be implemented in many database engines. We can implement tables in Excel. We can implement tables in Access. You can implement a table kind of a structure even in Notepad. But we are chosen to use SQL Server RDBMS, Relational Database Management System. And this RDBMS this is the tool. This is given by Microsoft. So we have to understand this tool, because we have to use this tool to implement the tables, store the data, get the data out whenever we want. All this happens when we are talking about a database management system. So a brief side, you can say a side note, is we have to understand there are many kinds of database management system. Like for example, we have Excel. Excel is also a database management system. It's a data management system. Data is managed, it is stored. Access is a database management system. But we are here talking about relational database management system, and that is SQL Server. Then we moved on. So you are able to see the screen now. So we moved on to understand what are the components in SQL Server. For that, the help of the tool that we take is called SQL Server Management Studio. So this is called as a SQL Server Management Studio. How do you get this? If you go to your start, if you have installed a SQL Server and Management Studio, you have to just type in SQL and you will get this studio. So you're able to see the screen. It is SQL Server Management Studio 19. So this is 19th version. So when I open this tool, the tool opens up in this manner. And here we have seen the first component is the SQL Server instance. So this is the first component. Within the instances, you have many server objects. These are called server objects, including databases. Our focus was on databases. So we said there are two types of databases: system database and user database. Then what is system database? I described the four databases. Yesterday we have seen and also summarized. So master, keeping track of all the databases in your SQL Server instance. Then MSDB for all admin related work. Then model is like a template. So whenever you're creating your user databases, model will be used as a template. TempDB is a temporary store. So as SQL Server database engine, a lot of things have to be done, like querying, inserting, updating, bulk insert. So now, while the table is getting queried, temporarily I may want to store it somewhere because every time I don't want to go back to the hard disk. So we use the TempDB database. Sometimes it is in memory, sometimes in the hard disk. But what happens is if I am not going to temporarily store, every time I have to go look into the file, open the page, and then get the data. You don't want to do that. You don't want to waste time. So TempDB is a store in hard disk, which is specifically used for this temporary tables or temporary data store. It is for our purpose as developer, and you will see more of it as we proceed. And these are your user databases. So we have seen the system and the user databases. So going through, we can see the logical architecture. This is called a logical architecture where the components are there. So one SQL Server instance, either default or named, we have seen in the previous classes. One has many server objects. So these are your server objects. Out of all the server objects, we are focusing on database now. So database can be system user. So we have seen what is the purpose of system databases, and then we have the user databases. Then every user database will have multiple database objects. So when you go to any of the databases, not only user, even system has, but user database we will see because we are going to be working with user databases. So this is your user database and it has multiple database objects. Now, each of these database objects is important, but we are initially going to start working with a table. So this is your table. This is where your data is going to be stored. So we won't worry now about the naming of the table. Why is it human resources dot department, etc.? We will not think about it. So it's just there. So now you have the databases. So system tables are there. These system tables inside your database indicates the tables which will store system information. Like you create tables. How many tables are there in this database? System table will tell you. How many databases are there in SQL Server? That master DB will tell you. So likewise, any information related to the database that is stored within the system tables. And these are your user tables. So these are system and user tables. You have the data. For example, if I consider human resources dot employee, it has the employee data. So I can go and take a look at the employee data. This is how it looks. Okay. You can see the result. So this is how the employee data looks. Now the question will be, where is this data stored? So this data is there. If you look at a file, if you put a Word file, you will store the data in Word file or Notepad. So where is this data stored? Then we came up with the next understanding that every database object like table will have data stored in file groups. So first we have to understand file group is decided at the level of the database. So we saw that yesterday. So we have this test or test example. At every database level, you saw that there can be multiple files and file groups. File groups are logical structures. So this is your file group. So here we are having two file groups. So primary and secondary. We said default is primary. Whenever you create a database, primary file group is created. And any file that you create, by default, one file will be created. You can add more files to the file group. So file group is like a folder. So how can you add the files here? The default file, every file group we have seen will have one file, and that data file is called as the default primary data file. The primary file group will have the default data file called primary data file. You can have secondary file groups. These are all secondary data files. You can have other files also, like in primary file group, I have this test example new. We have seen yesterday, primary file group will contain one primary file and multiple secondary files. You can have as many. There's a limitation based on SQL, but you can have more than 1, 2, 3. Then you have the secondary file group where you have the secondary files. So this has to be very clear. Now this was shown in the presentation. So we will see the slide once just for our understanding. This is the organization. I have a database. Database has primary file group. Whenever I create a database, a primary file group will get created. And primary file group will have multiple files, data files. The first data file that is there by default is called primary file, which is named as MDF. And then secondary files are many. Your primary file group also can contain secondary files. And your secondary file groups also can contain secondary files. Now, why the primary file is named as MDF or the extension is MDF? To indicate that it stores metadata. Metadata means data about other tables. So in this database, I want to store information about all my tables and all other objects. It will be stored in this file. Then what will be used? The other files which you create will be used for storing the database. So there are good practices as well. Okay, so we have seen primary data file MDF, secondary data file NDF, and log files are also there. Log file stores the operations that you do on the database. Why you have to store the operations? Question will come. You store the operation because later in date, if I want to abruptly stop the operation, I have to choose to undo or redo. Like in your Word document, you have that undo. You make a mistake, you say undo, or you say redo. So the log files are meant to store to what level should I undo? What are the steps that I have already done? And to what step I want to undo. So all that information is stored in the log file. And every data file will have data and log file, both will have logical and physical names. So this is your logical and this is your physical name. So you can see this is your logical name, it's given here. And this is your physical name. You can say the file name. Okay. Now, the file groups, you have primary file group. We have seen it majorly contains the system tables information. Then you have user-defined file groups. The primary file group is default file group by default. And you can have many files inside every file group with different sizes, and you can have them in different hard disks or disk drives. And how is the file filled? It is filled using proportional fill strategy. So I have many files here. So you will ask, how do I fill this file? If I have one file which is 2 GB and another file which is 4 GB, and I have 3 rows. So one row will go into 2 GB and the other 2 rows will go into 4 GB, because what is the ratio of the size? 1:2. This is 2 GB, this is 4 GB. And this is how they separate the data into different files. So file group, the folder will contain different data files, and the data files, the data is distributed in the same ratio as the size of the data. So therefore, size of the file. Therefore, it is called proportional fill strategy. Now, file groups. There are certain file groups where you can have tables, and these tables you don't want others to change. Like for example, currency exchange rate for a bank. In the morning, they add this table. I don't want the users of the bank or employees of the bank to change the currency exchange rate. So therefore, it will be created and it will be used along with the file group marked as read only. File group also forms as a unit of backup for administrators. So they can do a backup of the file group. And you can specify a table to be placed in a particular file group. So the link will be there. Table will be linked to a file group. File group will have files, and the data of the table will go into the files corresponding to the file. Okay. So this is how it is done. So you cannot not a specific file. So you cannot relate a table to a file. You can't say this table data will go into this file. You can't say that. You can say this table data will go to this file group. So all the files in the file group will contain the data of the table. Okay. So to summarize what we just saw, so that it is easy. So summary is this manner. So you have the server. Server has databases. Databases has tables. Then databases have file groups. Now file group, the default is primary. So one primary file group should be there. Primary file group, this is like a folder. Then you can have many more file groups. So like for example here, so you have the secondary file. And this is your secondary file groups and primary file group. Now in primary file group also, you can have primary file. And in primary file group also, you can have other files. You can have secondary. One should not confuse the secondary files and secondary file group. File group also, other than primary, they are called secondary. That means they are named. This is my secondary file group. Again, in secondary file group, I can have secondary files. Now, when you have a table, when you're creating a table, you can link the table to a particular file. So this is how you will link. This file group is there. So you link the table to, in fact, a particular file group. You can say this is my file group. I have this table here. And let us say this table is T1. And this T1 will be linked to a particular file group. So now table T1 is linked to the primary file group. But good practice is, if you have created your own table, it's always good to link it to the other file group. So if I link the table to one file group, then it has files. So the data in the table, which you are seeing here, you see this data here in the table. The data in this table will go and sit in this file group. When it sits in the file group means what? It will sit into the files inside the file groups. Now, within files, you have something called pages, extents. We are not getting into that because that is physical level. So this is only the logical architecture. So the logical architecture is this. One server or server instance, we call it as, can contain many databases. One database can have many tables. Each table is mapped to a file group. A database can have many file groups, and each file group, the file group is either primary or secondary. Primary is the one which is created when the database is created. Secondary you create. And in turn, the file groups will have files. The first file that we have is called as the primary file. And therefore, these are the two files that we are having, two types of files. And the data from one table is stored in this file. Okay, so this is how it is done. Now let us move on to the next part. So designing file groups, there is no need for file groups more than primary file group for small database, only for other databases. So you create files in as many disks as possible. That is the point. So that the data is spread. Then use to place specific objects in specific disks. For example, if I create a file group, I will be able to say T1 is in primary file group and there is a primary file. So this primary file, let us assume that is in C drive. Then you have secondary file. The secondary file is in D drive. So what happens? The same data from table T1 goes to C drive as well as a file in D drive. So data is distributed across different drives. Okay, so use to place specific objects in specific disks. So you are going to be using the specific T1 table, data goes in C drive and D drive. Suppose you have F drive, you can use here F drive. So any table, let us assume that T2 will have a data, and suppose I map T2 to secondary file group. Okay. Now T2, table 2 is mapped to secondary file group. Its data will go to secondary file in secondary file group, which is present in F drive. So the data is very well distributed. Now, this is what we mean by use the file group to place specific objects in specific disks. Then placing tables in joins, we will see these two. These two may not be relevant immediately, but we can have two tables and join the two tables. You can have the data in different file groups. And then you place the table and index in different file groups. So you have both of them in different files. What is index? We will see later. What is join? We are going to see as we proceed. We will come back to this if needed so that you understand, okay, this is what was said at that point in time. So this is the purpose of file groups. Then we have files. So before going to files, let us look at one more type of file, transaction log file. I've already specified that. So transaction logs are usually kept in different physical drives compared to the files which contain the data. Okay, then files, objects that are heavy and compete for space should be kept in different file groups. I should not put all my tables in one file group, and we'll be looking at that. Then the file within a file group is accessed using a separate thread. Multi-threading is there. So accessing table will be faster. If you are from programming background, you will be able to appreciate multi-threading. Multi-threading means what? You're simultaneously accessing the two tables. So if you put the two tables in two different file groups, you can simultaneously do the access. Then the table and its clustered index should reside in the same file group. You don't have to worry about that part. Again, when we cover index, we usually cover index as part of the advanced training. And if we have time here, we will see what it means to have the same file group. So this is your designing of file groups. Then within the file group, you have to manage the growth of the files. So let us go and see. Each file group will have multiple files. So we have seen that here, the file groups, we have multiple files. Okay, so like 2 files in here. You can specify the files. You can specify what all can be specified. If you see, you can specify it stores the data of the row. Okay, it also specifies what is the initial size of the file. It also specifies how the file grows. Okay, so 64, right? So this is 64 megabytes. Example, this is the initial file. File size, initial file size is also there. So you can specify the initial file size. You can auto grow. So that information is also present. So should I grow the file when data comes in percentage or in 64 bytes? Then maximum file size is limited to 100 megabytes. So you can limit the file size also, and you can say let the file size be unlimited. So you can do both of them. So initial size of the file is given here, which is 8 MB. And you can increase the size of the file. Initial file size can be increased to whatever MB you want. So what happens? This is called a file, a specific type of a file. It is called a sparse file. The file will have initial size, and as you pump data, the size of the file keeps increasing. Now the question is how much it should increase. That also you can specify. We have seen that. So to summarize, you get the initial size. You can also specify by how much you want to expand the data. So you have unlimited growth, you have limited growth, and you have incremental growth in percentage. So this is the option that we have. See, expansion can be manual expansion and auto expansion. So what do we mean by manual expansion and auto expansion? Here, you look at the files and you see the auto grow. The option is there. So you can see enable auto grow. This is called automatic expansion. Manual expansion, if you disable this, then you will get an error saying that the file is full. I can't do anything more. Then what you do? Then you have to go and increase the size of the file. How do you increase the size of the file? Going here. But that is not a good methodology. So usually what they do, they will enable the auto grow. So let the file grow, but it cannot grow infinite, because what happens? The disk is full and then there is a problem. So therefore, there will be a limit. So usually they will allow the file to grow. They will allow the file to grow in certain percentage or certain bytes, megabytes, and they will limit the final file size to whatever it should be. So we can give our own. This is in MB, so 100 MB, 1024 MB, which is 1 GB. You can specify the sizes. So this is how the data goes and sits in your file, which is inside the file group. Then you can also shrink the file. Suppose the file is 1 GB, but the data is only 500 MB. 500 MB is a waste of space, and it can be you can shrink it using manual option or auto option. So these are the shrinking. Then you have certain database options which are there. So if you go to the database here, right click, properties, you see certain options at the database level. So these are all called options at the database level, which are set for specific purpose. So the main purpose is how the database is going to function. Which features do the database support? So this is basically done to these options. And you can also specify the growth option and the shrink option. Auto shrink on. So you can see here true and false. So this will ensure that if the size is too much and I need size of disk space, then I have an option of auto shrink. So whenever the data is not available, but the size of the file is whatever GB it is, shrinking will happen to 500 MB. If the data is only 500 MB, it will shrink to 500 MB, not exactly 500 MB, a little more than 500 MB will be given. So this is how the data is. So you can see, you can have other options as well. It's not only the shrinking option. And each of these options get relevant based on the topic we are covering. Yes. Anybody had any question? Okay. So this is the logical architecture of SQL Server. Now we are going to get into something specific to table. So before we proceed with table topic of table, we have to understand tables get created by the process we have seen, and those tables are available. So usually it will be given to you either in an Excel format or maybe in a tabular format in Word document, whatever it is. So I'll show you the Excel format which is created so that you can see how the tables are given to you. And then this is how we actually, one moment. I'm going to stop sharing so that I can share the Excel with you. Okay. So whatever you're seeing now has undergone a process that you would be seeing now as I'm sharing, has undergone a process of optimization, and then the designer has created optimized set of tables, and he is representing this table using Excel. So for example, here I have voucher master, and this is the final voucher master table. So voucher master table. So this is this example that I'm giving is with respect to selling goods. So you have the receipt. In your receipt, that is also called voucher. So data is stored. You can see there is voucher master, and then you have voucher details. So you have one table, which is the final table is called, here we are naming it as 3NF because it goes through the process of what is called normalization. So you have voucher detail table where you have the voucher number, books are purchased, so book ID, how much quantity the book is purchased, and for discount you have the slab and the amount. So you have the voucher details. Then you have the book discount. So you can see here books and book discount. So you have the book table, which contains the name of the book, the title of the book, and the price. Just few sample I have taken so that it is easy. Okay. Yes, Naveen. Yesterday's recording is there very much. So people are asking whether recording is there. Yes, yesterday's recording is there, and today's recording also is being done and will be shared with you. So this will be done. So you have to, Naveenji, you have to give the URL. You have to give your information. I will be posting a URL at the end of this session. You give the student information and they will give you the recording and they will give you access to everything. Once payment is done and you confirm your presence in the training. Okay. I went a little fast in the initial phase of this class because we have covered everything in the previous two classes, which were part of demo sessions. So that's the reason why. Few more things because we have got an interruption now. So we have paused now. So few things I would like to mention as we proceed in training. Any difficulty in understanding or any question you can ask immediately. You don't need to wait for the end of the class. Okay, so that is one. And any suggestions with respect to changes you want, you can give at the end of the class. I will ask for 1 or 2 days, and you can give the suggestion with respect to speed, with respect to methodology. You can tell me if you are comfortable, not comfortable. We will see. We will take the maximum consensus and go on. So I hope the doubts are cleared. So I'm proceeding further. So you have books. This is one table. Voucher is table, books table, then discount. Discount on books is another table. Then you have the customer table, which gives me the customer information. And then you have discount table for the price. Price means there, if the bill is 1,000 rupees, you have some discount. If the bill is 3,000, you have some discount. So discount related tables are there. So this is the tables that we have got. This is how you will be getting the table. And now you have to go to SQL Server. Sorry. You have to go to SQL Server to create the tables. So how do we create these tables? This we are going to see now. So I'm going to create a database called ABC Bank. So when you're creating a database ABC Bank, we already know that you have an option to add file groups. And the good practice always is to add a file group, which is secondary. Sorry. So why it is important to add a secondary file group? Because this file group is where you want all your user data to sit. Primary, you should not usually touch. It is always the secondary file group. So I have no files now in the secondary file group. I can go here, and after I finish my creation of databases, setting the option, you can add the file or you can add the file here itself. So I will say here, I would like to have ABC Bank secondary file group, secondary file in the secondary file group. So I have specified 8 MB and 64 MB growth. I have right now specified unlimited because we are going to only use it for sample creation. And then I can also decide where to store physically. So this is how I have created a database. Okay. Now, whenever you create a database, you will notice that the file groups are there, but the major thing is the file groups are default. Now, the problem by setting primary file group as default is when you create a table, it will go and sit there. You don't want. So you say default is secondary and you say okay. So what will happen whenever I now start creating the table, I will be able to say that this table's data will go and sit in the secondary file group. So my table data will be sitting in the secondary file group. So let us start with a case study or example of bank. So like how you saw this table, okay. Similarly, you will also be looking at how to create a table in SQL Server. Sorry, I think I have not been sharing the SQL Server screen. So let me share the SQL Server screen. Okay. So this is how we have created a database, ABC Bank. In the database, we have created the file groups secondary, and I have created the extra files, and I have said that extra file that is created will go to the secondary file group. And here I specify the secondary file group as default. I'm repeating this because the sharing was done for only the notepad or the Excel. So this is how it is. So I say okay. So this created the database. Now, where should I create the table? So it is a bank database. So we are going to start creating our own user tables. But I can create the table based on the input given from such an Excel sheet. So somebody will give an input. These are the tables you have to create. All the 3NF, these are the tables. And you have to link those tables. So how to link, etc., we will see as we proceed. So up to this point, is it clear? Is there any doubt up to this point? Any doubt? Okay. So there is no doubt. So we will proceed further. If there are any doubts, let me know. So now let us go to the next portion. How do we create tables in databases? So to create tables in databases, we first have to understand that there are 3 constraints. So let us understand that how table is designed. Whenever table is used to store the data, the first type of constraint we have is called as a data constraint. Data constraint means you're going to store the data in the table. You have to specify what is the data type. Why do we specify the data type? Otherwise, what will happen? In one row, you will be able to store data in date and time. In the same row, in the same column, somebody will try to store data as text. But I should not allow that. So that is why that is called data integrity. So whenever I am inserting data into the table, the first important thing is it should follow a particular data type. And this is called data integrity. The second that we look at, so first is data integrity when you're inserting data. So you have to decide what is the data type going to be. Then comes entity integrity. Entity integrity means what? Entity integrity means I have to ensure that the row is uniquely searchable. Any row in the table, I should be able to uniquely find that row. And how do I uniquely find that row? That is done through certain keys. We call it as key here. We have primary key or you have unique key. They are also called alternate keys. So unique keys are also called alternate keys. So you have primary key and then you have alternate key or unique key. In data integrity, you have data type. We will see the importance of each one of this because we are going to see creating the table. And the third type of integrity is called business integrity. So the entity integrity ensures that each row can be identified uniquely, like employee ID. We'll see one example that we have seen in this. So in this, you can see here, there is business entity ID. So this is called as the primary key. This is unique, national ID number. National ID number is like your Aadhaar card number. So the national ID number is there. Therefore, you can clearly see that there are columns in the table. These are called columns. And these columns will have information about something. So in this case, information about employees. And each column will have a particular data type. And out of all these columns, you can take one column to be unique or more than one column. Here we have business entity, which is unique ID, and national number, which is a unique ID. So you can use any one of them to search for one of the employees out of many. We can also have employee ID. So that is up to the business, how we do it. And as we go further, we will be able to see. Then you go to business integrity. Business integrity means what? Simple business rules related to data. So like I am talking about bank. Now, when I say bank, so you will have obviously certain rules related to how much of money can I withdraw at a time. Then how much of money I can deposit at a time. We will have these rules. Now, these rules will affect the data and you will have to create some rules in the table so that you don't allow withdrawing cash. Suppose the limit is 25,000. You should see that beyond 25,000, you don't remove. Then there is some minimum cash you have to withdraw, like 500 rupees. So you should see that withdrawal amount is minimum 500. One way is in the ATM itself, you say that only 500 rupee note will be dispensed. Second is you have to limit the data in the database. So the business rules related to the data will be specified when you specify business integrity. So whenever you are entering data, it can even be Excel or Access. These integrities are important. So whenever we talk about relational database management system, the entity integrity becomes important, relation becomes important. Then what is the fourth type of rule? These are all rules related to data, rules related to the rows that are entered inside the table, business rules related to the rows entered into the table. Then we have something called referential integrity. Now this referential integrity is to maintain the relation between data. And how is it maintained? Like how we have primary key and foreign key, unique key. Here we maintain it through foreign keys. Each one of them we will be seeing. Okay, so foreign keys. Now let us first go to data integrity. So we are now going to create a table. Initially, we will see how to create a table using the user interface. And then we will see how to create the table using the code. Okay. So here I'm going to be creating the table. One. Okay. So this is my ABC bank. So bank has certain tables. So first I create a table called branch. So bank will have multiple branches. So I create a table. And in the table, I have columns like branch ID, which will give me the branch detail. And data type is integer. We will look at what are the various types of data later. So I'm just showing you how a table is created. So I specify the data type. And then I specify whether the data is optional or mandatory. Sometimes the data can be optional. Like suppose in a branch, you are having, say, some branches have lockers, some branches don't have. Then locker availability is a data, optional. It's not necessary it has to be filled. It can be empty. So when you want to say that the data can be empty, you have to say allow nulls. But here branch ID cannot be empty. Every branch should have a branch ID. Therefore, you say don't allow nulls. And then we go in and we say, what is the name of the branch? You can have names based on the areas you can name. Like in Bangalore, we have MG Road, then Jayanagar, JP Nagar. You specify. And this has to be of a particular data type, character. So we say character 10. Then you say, should I allow nulls? If you want the name also can be optional, you can say allow nulls. This is the branch ID. And you can also have address of the branch. And you can specify that it has to be a character, let's say 20. Okay. Suppose it is also optional. You can leave it optional or you can make it mandatory. This is how we create a table with columns. Out of this, we choose one column to uniquely identify the rows in this table. And that one column is called the primary key. Why is it called primary? There can be many unique values, but one of the columns will contain unique value and that column will be used for searching the data. So that is why it is called primary key. A column with unique value, which is used for searching the data, is called primary key. And here the primary key is branch ID. Then you have name, address, etc. This is how you create a table. This is your data type. And why this data type? What are the different data types? We will see later. So this is how it is. And then you save this. And once you save, it will ask for the table name. And you can say the table name is branch. Okay. Now, for any of the columns, I will have certain properties. So we will look at these properties to understand what are these properties. You are going to store data in the columns. So some property is required. So first property, should I make the column mandatory or optional? You can take this as when you are filling the form also, you have certain fields which are optional and mandatory. So that is how it is here. So some are optional, some are mandatory. Then what is the data type? Then what is the default value? Suppose you want some default value, you can specify the default value, like or address, or there you default value you can say Mumbai. Suppose the branch is going to be, all the branches are in Mumbai, by default you can say Mumbai. So that way you can specify the default value, and then these other options like collation, we will come to it later. You can also have a calculated column. We will look at some calculated columns as we proceed further. Okay. So we specify the data type and other pieces of information. This is how we create the table and you save the table. So a table is created here. So if I refresh here, you will see the table branch. Now, within the bank, you can also have another table containing information about the account. So I can create a table called account. So again, I can specify account ID, account ID. Then, of course, I have to specify the customer. So what we will do is quickly go and create a new table for customer. So new table, we will create customer. So you have customer ID and you have data type, which is integer. And you will say, don't allow nulls. You need the customer ID information. Then you have the name, character. 10 characters I'm keeping. And there also you should not allow null. These two are enough. So customer ID and name. So I say save. And I will name this table as customer. So this creates the set of tables, branch and customer, two tables. Now we will create the third table, which is called account. This is the account table where you will have account. So let us keep account ID, which is an integer and which will not allow nulls. Okay, so this we can do. Then we have the branch ID from which the account is going to be, in which the account is opened. Okay, so this is the branch. Then you can have a balance. I will talk about what this balance indicates as we proceed. So I can say I want it to be of money data type. And then you have unclear balance. So you have two balances usually. I will talk about what are they as we proceed further with the exercises. So you have two. Right now, just pay attention onto the data type and the columns. And both of them are mandatory to be entered. Branch ID is mandatory to be entered. Now I have to enter which is the customer. So customer ID also I require. So I have account ID, I have branch ID, I have customer ID, and this is integer. Now, with this we will finish creating the account table. Simple account table, just to show how it is done. Now, one important thing, this account is having the branch ID, account table. Which branch have I created the account? Then the customer who has created the account. Now the question is, from where do I pick the branch? From where do I pick the customer? So you already have the branch table and the customer table. So what you do, you build a relationship. This is how you build a relationship. You can add two new relationships. It will say you want to add a relationship from which table to which table. So you can say, I want to add a relationship from the branch table, and in the branch table, I want to use the branch ID column, and the branch ID column should be used as a reference for the branch ID column which is created here. That means you cannot have a BR ID in the account table which is not present as branch ID in the branch table. This is called referential integrity. More we will see as we proceed, just to show you one relationship. And this is how we create the table, and we also create the relationship between the table. So branch and account has a relationship. Similarly, you can create another relationship, which is for customer. And so I go for customer, and from the customer table, I pick up the customer ID, and in the account table, the customer ID column will reference this customer ID. Therefore, there will be no customer who is not present in the customer table. So that is, you are ensuring. Okay. So he's saying the column in the customer table, customer, does not match an existing primary key or unique constraint. So I have to put the unique constraint here. So that is why that we will see later. So basically, I will close this for now.